everyone. So today in this lecture, we will see how the present worth method is used for the analysis of cash flows and for the comparison among different alternatives. In our previous lectures, we have seen the relationship between various factors like between P, F, A and G. We have the relationship among all these factors. And we have seen how the equivalence of cash flows, they are established. In this lecture, we will be analyzing and discussing the present worth method used for the analysis of several alternatives if we have to select any one alternative among the several available ones. We may compute the present worth of different cash flow diagrams, how the transactions that is the profits and the disbursement in total, they can contribute towards the monetary value at the present point of time. Now, selection among different alternatives, we have various methods. So present worth method is one among the listed one. So we may have a present worth method for the comparison among alternatives. We can opt for the uniform annual worth method, sometimes also termed as equivalent annual worth method. We have rate of return and we have cost benefit ratio. So in the present lecture, we will be just focusing on the present worth method or the present worth analysis. Now in present worth analysis, what we do, we basically convert or change all the alternatives into an equivalent present economic consequences. That is, in this, we will evaluate the net worth of all the transactions that are there in a cash flow at the present point of time. Present worth analysis is frequently used to determine the value, the present value of the future money receipts and the disbursements too. The criteria of selection, if we are using the present worth method, is that if in a given cash flow, we have only net receipts, that is the cash inflow, then we have to select the one which is having the maximum net present worth. However, if the cash flow just contains the disbursement, that is the cash outflow, then what we have to do in using this particular analysis, that option will be selected for which the present worth is minimum, since these are the expenditures. So the option with the less expenditure will be the preferred one. However, if in a cash flow we have both the receipts and the disbursement, that is the cash inflow and the cash outflow, then we have to compute the net worth by subtracting the inflow minus outflow, and depending upon whether it is the profit or the loss, we have to decide accordingly. If it is a profit, then the alternative with a maximum profit is the preferred one, and if we are having a loss, then the option with the minimum loss is the preferred option. Now, this is how we go for the present worth analysis. Say we have a typical cash flow diagram as shown here. So the cash arrows pointing in the upward direction, they represents the benefits and the receipts or the cash inflow, and similarly all the transactions which are pointing in the downward direction, they depict the cost or the disbursements. Now we can calculate the equivalent worth, that is the present worth of all the benefits at n equal to 0 or at t equal to 0. So that is shown by a yellow bold arrow. Similarly, all the disbursement and the cost, we can compute the equivalence of all these disbursement and the cost at the present point of time. That is here depicted by a blue bold arrow. And of course, the net present worth is the subtraction of the two. So we accept the alternative with the highest present worth value if the net PW comes out to be positive. That is the maximum profit or the maximum return. Similarly, if we have the net present worth coming out to be negative, it means that the expenditure is higher than what the income is. So on this, we will be selecting the one which is having a minimum loss or a minimum amount of investment. So this is the decision rule which we apply when we are carrying out the present flow analysis. Now, whenever we are doing analysis using the present worth method or say any other method like the EAC equivalent annual worth method or the future worth method, then we have two conditions. Either we have the comparison of alternatives with equal lives, or we may have a comparison with alternatives that have unequal lives. So that is shown here. Say for example, if we have a cash flow for asset B and asset C, we can see that if we are comparing these two alternatives, both these alternatives, they are having the same economic life, that is of 7 years, say for example. So this is an example of the comparison when we have the equal lives of the asset. Similarly, if we see asset C, the economic life of asset C is, in this case, is say 4 years. And if we compare this asset C either with asset A or asset B, then this is a comparison among alternatives with different economic life. So in this lecture, we will be just focusing on the problem involving equal lives. In coming up lectures, we will be dealing with unequal lives as well. So just to explain how the analysis or the calculations for the present worth method is being taken up, let us discuss one problem. The problem is that we have 3 robots, and for each robot the different first cost, that is the initial investment for each of the robot, the operating and the maintenance cost per year, the expected income from each of the alternative or each of the robot, and the estimated salvage value. That means whatever is being earned when this is being sold when the economic life is equal. So these different values for these options are given for each robot A, robot B and robot C. So what we have to do, we have to compute that which robot is the best one to select. Of course, the economic life of all the 3 options, they are given as 3 years and the interest rate is given as 12 years. So we have to use the present worth method to compute the best option available with us or the best robot which we can select from the available 3 robots. So let us see how we are going to solve this problem with the help of present worth analysis method. The very first step to solve any cash flow problem is to draw the cash flow diagram. So let us draw the cash flow diagram for robot A. So the economic life of each of the option is same. It is given as 3 years. So 0, 1, 2, 3. So the life is given as 3 years. So the cash flow will be of 3 years for each of the option. Now the first cost is basically the initial investment that is being made. So the first cost for A is given as $55,000. So this is a cash outflow because this is the initial investment which is to be made either to acquire this robot or maybe on some maintenance or its purchase. So this is the first cost, is basically the initial investment. Now maintenance and overheads they are given as dollar 3,000 each. So these are the annuities, and the value of these is dollar 3,000 each. Now there are net earnings of dollar 40,000 each starting from the first year of operation. So these are the earnings, so they will be depicted in upward direction. So the monetary value of these earnings, they are 40,000. And apart from this, one more thing is given, the salvage value. So the salvage value is basically the resale value of any gadget or equipment. So once the economic life is over, this machine or this gadget may be sold, and the salvage value basically reflects the earning. So this is the salvage value over and above 40,000. So it is given as dollar 4,000. So this is the cash flow for Robo A. Now what I see here, that we have two series, uniform series or two annuities. So they are at the same point of time. So arithmetically we can add and subtract if there are many transactions at the same point of time. So if I just redraw it, just to simplify some of my calculations, I may redraw this cash flow like this: 0, 1, 2, 3. So this is already at the present point of time. Now 40,000 and 3,000. So each transaction at a particular point, one transaction is upward, one is downward. So arithmetically we can add and subtract them. So if we just subtract this 3,000 from 40,000, this comes out to be net earnings of dollar 37,000 each. So dollar 37,000 each. 40,000 minus 3,000, so 37 each. And of course the salvage value remains as it is. So this is dollar 4,000. So if I just compute the net present worth of this cash flow, so again, just for explanation, I may split this into three parts. So we have one transaction here, dollar 55,000, which is already at the present point of time. We have another series where we have annuities starting at the end of year 1 and continuing till the end of 3 years, of course, of each of dollar 37,000. And we have another series where we have a future transaction inflow of dollar 40,000. So these are the three standard series which one can visualize, which are present in this cash flow. So this is already at present, this one is already at present, so no need of any conversion. So I straight away I will write, if I am calling this as P1, straight away I will write P1 as 55,000. Now if I am interested in finding out the equivalence of this at this point of time, let me call this as P2. So the direction of P1 is downwards. Now if I am interested in finding out P2, so P2, of course the direction of P2 will be upwards. So it will be, if I just write down the formula between A and P, so it will be 1 plus I to the power n minus 1 upon I 1 plus I to the power n. If I fill up the numerical values, A is 37,000. 1 plus I is given as 12, so it will be 1.12 to the power 3 minus 1 over 0.12, 1.12 to the power 3. If I compute this, this comes out to be $88867.756. So this is the second transaction. Now on similar lines, we can compute from this series. Say if I call the equivalence of this at this point of time, let me call this as P3. So P3, again, the direction of P3 will be upward. So we have to treat this as F, and we are interested in finding out P. So the relationship is F equal to P1 plus I to the power n. So if I just find out the value of P, it will be F upon 1 plus I to the power n. F is given as 4,000 divided by 1.12 to the power 3. So this comes out to be $2847.121. Now the present worth for robo A, this will be equal to, now we have to keep in mind the direction. So P2 and P3 both are upwards, so P2 plus P3, since they are upwards, so I am treating these directions or these with a positive sign, and since P1 is downward, so it will be negative with a negative sign. If I compute this value, that is 88867.756 plus 2847.121 minus 55,000. So this comes out to be $36714.876. So this is simply the present worth of robo A. Fine. So this is the present worth of robo A. On similar lines, we can draw the cash flow for robo B and robo C. So just for your convenience, I may write the formula directly. So if I'm interested in finding out the present worth of robo B, it will be, so PW robo B. So if you draw the cash flow and you just write down the expression, it will look, the expression will be like this: 939,500 1.12 to the power 3 minus 1 upon 0.12 1.12 to the power 3. So this is the conversion of annuities to the present point of time. The second term is basically the conversion of salvage value at the present point of time. And of course, the third one with a negative sign is the first cost. So that is to be subtracted. So if I compute this on similar lines as we did for robo A, this comes out to be 41143.016. So this is the present worth for robo B. Similarly for robo C, if I just write down the expression of present worth for robo C, this will be 34000 1.12 to the power 3 minus 1.12 1.12 to the power 3. Conversion of annuities to the present point of time. Then the salvage value, treating this to be the future worth and converting it to the present point of time, and again subtracting the first cost. So if I compute this comes out to be $31509.384. Now if I just compare all the three presents, since all these costs, they are in the positive directions or they are the net earnings. So for Robo A, it is 36714.876 dollars. For Robot B, this is $41143.016, and for Robot C it is $3,509.384. Since these are the net earnings, so the objective is to maximize the earnings. So if we just have a look, then we can easily see that this is the particular machine or the robo which is giving the maximum earnings in its economic life. So this will be the preferred option. So the answer to this is Robo B is the preferred one, with present work coming out to be $41143.016, or these are the earnings or the cash flow upward, or these are the net. So this is all for today's lecture. We have seen how the present worth method is used for computing the present worth of any cash flow. So if there is no 3 robots available, just 1 robot is available, and we wish to compute the equivalent present worth of any one of the robot, then we can also do that. We have seen that how the present worth method is used for the comparison among alternatives. Of course, when the economic life of all the alternatives is the same. So thank you very much, and in our coming lectures we will be discussing the problem based on unequal lives as well. Once again, thank you very much.